Good evening, everyone. Let me introduce myself first. My name is Maxine Singer. I'm the former president of the Carnegie Institution, and I am the chairman of the board for Math for America, DC. I thought I'd just tell you a little bit about where you are. If you just look around the room at the murals and the ceiling, you will know right away that the institution is about science. It's about science and science education. Until about 25 years ago, all the education efforts were directed at advanced education for graduate students and postdocs. But beginning about 25 years ago, we began a series of programs that are designed to try to improve the teaching of math and science in our DC schools, public schools and public charter schools. And Math for America is the youngest of those programs. It's been in place now for 5 years, and it is the proud sponsor of this event. My only job after all that is to introduce to you Will Stafford. Will is a math teacher at Two Rivers School. I'm sorry, at E.L. Haynes School. Beg your pardon, Will. And he is also a master teacher for Math for America. The master teachers are part of the program. It's for people who have been teaching math for 4 or 5 years here in DC, and who apply and who are willing to go through the requirements for that program. And then they participate with our fellows who are in training to be math teachers and do professional development for themselves and for the math fellows. And we're very proud to have Will be part of that. And so I will now let him take over. Okay, Will.
All right, thank you so much. Good evening and welcome to the first DC Math Ignite Night. We are so excited to see you all here, a collection of math teachers from across the city. As Maxine said, my name is Will Stafford. I teach math at E.L. Haynes High School, and I'm a master teacher within the Math for America DC program. There are 2 purposes for tonight's event. The first purpose is for you to see an idea that you can try to take back to your classroom. And the second purpose is for what you've already done, connect with other math educators across the city that are passionate about teaching math and have some time to talk about new ideas as we head into the school year. Like all appropriate math professional developments, my goal is that you have one thing you take away from today's session. So one idea you latch on to. You have 9 different talks as we go through the night, and so try to choose one. You've got a little note catcher if you need it. These talks are going to be recorded, and so you'll have a chance to share them with your colleagues if they didn't get a chance to make it through the rain. I appreciate you coming out in the rain tonight. Tonight's going to run like this. Each speaker has 5 minutes to present their professional development. In between each of the speakers, we're going to raffle off some snazzy prizes for you to take back to your classroom. We had a huge budget of $100 to spend on this evening, and so we've got some pretty nice prizes. One of the themes of tonight's work is one thing that we want to think about changing and improving in our classroom this coming school year. The only interactive portion of this evening is tonight. I'd like you to turn and introduce yourself to a partner, tell them where you teach, and tell them one thing that you want to improve in your practice this school year. All right, 30 more seconds. All right. Thank you so much for jumping right in to talk with your colleagues. All right. Let's go ahead and get started. I'd like to welcome our first presenter, our first brave presenter to the stage, Theresa Simmons. Theresa is a Math for America master teacher, a nationally board certified teacher, and she currently teaches at Friendship Collegiate Public Charter School. When we asked Theresa what she most wanted to improve in her practice for this coming school year, she said, submitting her lesson plans on time and not leaving all of her grading to her student teacher. Let's give a big warm welcome for Theresa.
Good evening and welcome. My name is Theresa Simmons, and like Will said, I teach at Friendship Collegiate Public Charter School, and tonight I want to talk to you about your walls. So think back about 50 years ago into the 1950s and the 1960s into what a classroom would have looked like. It might have looked like something like this, or like this. Straight lines, feet forward, blank walls, suitable for learning. And then fast forward to maybe when I was in college, 1994-ish, and this is what my classroom looked like. Oh my goodness, wait a minute. This is actually 2014 in April when I took my children. Nothing had changed in 20 years. Blank walls, nothing to see. All you saw was something that was drab, dull, and boring. Absolutely nothing going on here. And so we all know, because we've read all kinds of educational and professional books and things, that we need to do something about these boring walls. We need to have walls that inform, walls that display, walls that teach, walls that talk. And I don't mean of the Disney variety that scare all of your children. Making your walls talk is a way to engage, enlighten, and establish independence among your students. And I want to show you 3 ways that you can do this with your walls alone. But first, a disclaimer. I don't mean all those lovely pre-made posters you can buy from the educational store, like these. And I don't knock them completely. You'll see them in my room. But I mean, as my favorite chef, Emeril Lagasse, used to say, kicking it up a notch. So the first way to do this is to nix the obtuse professional language for intellectually accessible language. So someone doesn't have to have an education degree to understand what it is you're trying to say. And none of our children have education degrees, by the way. I mean, get rid of words like agenda, essential questions. What are those? Objective. Kids don't really know what those words mean. And we use them every single day, sort of hoping that they'll figure out what they mean. And most of the time, they don't. I'm talking about replace them with phrases like, what will we learn today? How will we learn it? By the end of class, I should have discovered this. How I demonstrated that I learned it. How will we practice what we've learned? And these phrases are accessible to all students and really give a more true meaning to what the jargon indicates. So this is how it looked in my classroom last year. Couldn't miss it. Now, I will say that I did put the professional jargon at the bottom for the sake of my administrators who come to grade our classrooms. But for the most part, this is how it went. Next, incorporate a self-service station. So we don't live in New Jersey, and so when you pull up to the gas station, a nice fella is not going to come up and pump your gas for you. And most of us probably don't do grocery delivery. So we want our students to serve themselves. Miss Simmons, can I have some missing work? Sure you can. Right over there on the ledge. Go get it yourself. We sort of do too much for our kids. We need to develop some independence in them and give them the opportunity to do it for themselves. Give them a grade report and let them get it themselves. Got tutorials? Post their names on the wall. Let their friends hold them accountable for getting there. And if you want to, give it a nice little name like Tuesday Thrillers or Thursday Test Busters. Lastly, we want to inspire and connect them to the world around them. And I don't just mean by word problems and real-world connections. So we all know that we've got DC Prep coming up, or that we've all done DC Prep. And it comes in different forms. Oh, sorry, Park this year. New name, similar idea. The kids have to be prepared. So last year, around February, my coach, Allison Crouch, came up with this great idea. And it was mostly great because she did all the work already. And so she wanted to give assessments every single day, and we would call it March Madness. I said, oh, this is fabulous. Now, what is March Madness without a bracket? So we made this wonderful bracket on our back wall, complete with names of all of my students. They competed against each other. They were semi-randomly paired together, and we watched the results from day to day. It was interactive. They could see their movements from day to day, see who they needed to beat out and win out. It was great. And so this year coming is the math clock. or some derivation of such, on my wall, and the early finishers board. I'm done. Now what? Self-service. So in conclusion, I just want to review, you can make your walls talk by getting rid of that obtuse professional language, using intellectually accessible language, getting a self-serve station, and inspiring and engaging with them by connecting them to the world around them. Thank you so much.
All right, thank you, Theresa, for getting us off to such a great start. So on the theme of walls that talk, our first prize for this evening, if you want to take your raffle ticket out, is this Einstein poster. Yeah, that's the appropriate oohing and eyeing we need. Do not worry about your difficulties in mathematics. I can assure you that mine are still greater. All right, so our first winner, 714349. Yay, all right. Okay, we'd now like to welcome to the stage John Mahoney. John teaches at Benjamin Banneker Senior High School. John is also nationally board certified. And when asked about what he'd like to improve in his classroom this year, he said he'd like to make it more, and he'd like his students to enjoy it more. We'd now like to welcome John to the stage. Thanks, John.
Thank you, Will. Before I start, I am honored and humbled to be here. This is such a great program. I was informally associated with Math for America when I was at PCMI, and it's just, Maxine, this is amazing. You know, who would have thought, you know, that here we are 6 years later, we're in our 6th year, that we have so many great fellows helping the kids who need the help in DC public schools, DC charter schools. So thank you very much. So, when I decided to leave my private school in the district and teach in public school, I wanted to teach at Banneker High School, and for a variety of reasons. But all I knew about Banneker himself was the standard, like, 3-paragraph biography, and there are often errors in that. So I went up to Baltimore and found a microfilm copy of his almanac. And it was in terrible shape. His biographer was a historian from the Smithsonian, a great biography of Banneker. But the biographer was not a mathematician and was not alert to Banneker's math. This is an example of Banneker's handwriting. I was assisted by a teacher in Malaysia to clear it up. Here's what it says. A question by Ellicott, the geographer general, divide 60 into 4 such parts, that the first part being increased by 4, sorry, timing a little bit, anyway. So Banneker did not know the standard Common Core algebra, and he used a math technique called single position. And it's basically a system of guessing and checking and modifying the guess. So here it is again. You'll see this slide's going to stick up for a while. So our idea is to divide 60 into 4 parts. The first being increased by 4, the second decreased by 4, the third multiplied by 4, the fourth divided by 4. And that the sum, difference, product, and quotient are all the same number. And so here's how the method works. You first guess a number, and you're guessing a value for this, quote, same number. And with your permission, we're all going to guess 16. But you may want to do this at home. So if 16 is the first number, okay? So the first one is going to be increased by 4 to become 16. So let's see what that's going to be. So our guess is 16. And the first part must be 12, because 12 plus 4 is 16, okay? Now the second part is going to be decreased by 4 to get 16, so you should be able to think ahead what that's going to be. Because 20 minus 4 is equal to 16, okay? The third part must be 4, because 4 times 4 must be 16. And the last part, something divided by 4, has to be 16. We can all think about that. And I hope you realize it's going to be 64. So now we want to add those parts together and to see whether they have a sum of 60. If they do, we are right, and we can stop. No, they have a sum of 100. So what we need to do is to modify our guess. Remember, we guessed 16. Our goal was to get 60. We got 100. So what we're going to do is we're going to modify our guess by a ratio. What ratio do you think we're going to modify it by? Well, the correction factor is going to be 60 over 100, or 3/5. And again, I apologize for this. It was running quicker than I anticipated. But if you multiply 16 by 3/5, you get 9.6. And the 4 parts of those decimals, and should have rehearsed it live. Anyway. So single position was a common method. Those of you who are at AU has a fantastic library in the archives of historic math. This is an example. This shows you Banneker's handwriting that was cleaned up, and you can see Banneker got the same answers. And his biographer says he knew the method of single position. There's a similar method of double position, which was common at the time. And the archives at American University are just fantastic of these old math books. My handout's available here, and it contains my seminal essay on Banneker, lots of examples of his mathematics. So again, I apologize for the slides, but thank you very much.
All right, thank you, John. All right, for DCPS teachers, I appreciate you coming out tonight. I know that for many of you, you probably don't know what classes you're teaching or what your classroom's like, but you could walk away with 12 protractors for your classroom tonight. And so I hope that puts you at ease in this stressful time. Our first winner for the protractors, only winner, 714319. Oh, all right, there we go. Okay, we'd now like to welcome to the stage my colleague Eric Jones. Eric teaches at E.L. Haynes Public Charter School, and when he was asked about what he wanted to improve in his math practice this year, he said math task implementation. Let's give a warm round of applause for Eric.
Good evening, ladies and gentlemen. So tonight I wanted to go ahead and talk to you about 360 Degrees Math with Khan Academy. So this summer I had the opportunity, and I'm going to wait for the slide to go on a little bit longer, to spend some time at Summit Public Charter School in California. And one of the things that we were trying to talk about was trying to create a classroom space that pushes student learning and accountability, all right? And so we had the experience of having some folks from Khan Academy and also some teachers there who had some experience with the movie Teach by Guggenheim. And in that movie, they had a clip talking about transforming your classroom. The way they attempted to do that was by taking all the wall space and going ahead and putting up whiteboards. So you see, I had the opportunity this summer, once I came back from California, was going to Home Depot, grabbing whiteboards and having them cut up, getting a liquid glue gun, and start putting it on my wall. My principal's over here. I don't know if she knows the whole story of this yet, so this is the first time she's hearing about this. So it took a good weekend, but it was a productive weekend. I felt like I really accomplished something. What was able to come of it was an opportunity for me to kind of transform my classroom, for me to be able to create that space that I really wanted to see, where whiteboards were all over the place. To be honest, I only have 270 degrees whiteboards. I didn't think to put it on the windows. But I'm going to stick with the name because I feel like it really represents what I'm trying to accomplish in the classroom. Along with being able to put the whiteboards up, we wanted to be able to work with Khan Academy. I'd always think of it getting 5 right in a row. I really feel like this kind of experience is really meant for students who are behind or students who are ahead. I've had experience to work with some of the developers from there and look and see some of the things that they've done. They allow you to have student recommendation and student ownership. The one thing about this is students can kind of deny you as one of their coaches, and they can also remove some of the things that you recommended from their program. The cool thing I really think about it is it takes a little bit more than just getting 5 in a row. Once you get 5 in a row, it's going to go to the practice session, and then it's going to give you an opportunity to level up and then to be able to get some badges. It has a very good tracking system and tells you in terms of the class the percent of students who have been able to master different skills, whether it be 15 skills, 31 skills, and whatnot. And then it's really key, and I really like this part right here, that it was able to really pinpoint where students were able to struggle. And I think that was part of the algorithm that they set up. I think that was really superb, and it was really able to pinpoint your instruction and your target needs. So now I took the classroom, was able to take the Khan Academy, and then had to insert the students. So this summer I had the opportunity to work with about 10 to 8 students for a 2-week pilot, where we brought them into the system, provided them with computers, whiteboards, and Khan Academy, and looked to see what they were going to be able to do. My expectation was that I wanted students to kind of be up at the board, writing, doing math. Some students just wouldn't stand up. They would just sit down. They would continue to show their work. But they were using the whiteboards. They were using it as a place for them to show their work. They were using it as a place for them to be able to ask questions. They were using it as a place for them to be able to monitor their progress. This is our image of our makeshift tracker that we had throughout the classroom. Once we were able to put this up here, we were really able to see students stay on track and stay focused. They would end up actually going home and then coming back with many more different things done. So now, overall, throughout the 2-week pilot, a group of 9 students completed nearly 30 hours of Khan practice, practiced over 10,000 problems, and, completed over 100 different skills. Now, I think this was one of the questions that I asked myself when I was ended up finishing up the classroom, finished up the pilot, was setting up the classroom this way, that it really pushed student learning and ownership. To be very honest and transparent, some students didn't take to actually using the whiteboards. Certain students still wanted to write their things down on pen and paper. I think one of the other things that I kind of take away is, in order to maximize student achievement, we must, it's going a little bit fast, we must be able to provide, students with the structure and resources to allow them the flexibility to find the best space and environment. I think the last picture that I had up there was just a picture of me loving Khan Academy. I think what they've done with their program, what they're allowing teachers to be able to do and students to be able to do both inside the class and outside of the class, I think is really going to be a game changer. And I'm looking forward to being able to implement it in my classroom, especially not only with the low achieving students, but also with the high achieving students. And I think all students in general will love to be able to kind of take ownership of their own learning. So thank you.
All right, thank you, Eric. Thank you. All right, our next prize is a book called United We Solve. One of the reasons I want to give this book away tonight is if you haven't had an opportunity to work with this book, it's a really outstanding title to write down. It's 116 cooperative learning activities that range from grade 5 through 10, and they're all structured in a way where kids get certain cards and they can't solve the question unless they actually talk to their peers. And so it's hard to teach cooperative learning because kids don't always want to talk to each other, and it's great that the activity forces them to. So if you don't win this prize, as most of you won't, I do encourage you to go and pick it up at Amazon. It's $20. It's well worth the money. Our winner is 714335. All right. Okay, we'd now like to welcome to the stage David Barnes. David works with the National Council of Teachers of Mathematics, our national professional organization. When asked what he'd most like to improve within his work this year, he said, improving the connection with early career teachers. Let's give a warm round of applause for David.
Thanks, Will. I have to say this feels like the first day of school, you know? All right. F. We're going to talk about the F word. Failure, right? That's one of the things we're always scared about is failing or failure. But what I wanted to do today is really embrace failing and what we can learn from failing. And there's a story about failure, and it's Apollo 13. And as I thought about this story, I realized that most of you were not around when this happened, and most of you were too young to go to the movies when the movie came out. But we're not going to talk about the astronauts, we're going to talk about Mission Control. And this is a picture of Mission Control. Kind of looks like a school, doesn't it? They've blocked out all the things from the outside, and you put a bunch of people in the middle, right? And they've got the technology, they're working together, they're looking at it. This was the technology of the day. They had limited information coming in, lots of choices, and up in the right-hand corner, do you see that? That was the phone. My son said, "What is that?" I said, "That's how they called people." He's like, "Epic fail." And this is the flight director, and that's who you are. This was Gene Kranz. He's the guy who made stuff run. That is who you are in your classroom. They are the ones that set the stage, get it all to happen. And one of the things that they did in Mission Control is about habits. They had habits to do things. They had binders. And in this talk, we're going to talk, this is one of our books, Principles to Actions. There's some messages in here. But how do you build the habits at school to do that? For example, raising hands, right? On the right-hand side, you see the multiple cups. Look up Dylan William. He has some ideas about using cups, because if kids can use their hands and do that, they can stop thinking. When they stop and do this, they stop thinking because you're waiting for them. And what about habits? Habits save you time. Somebody talked about handing out papers and doing that. Here's a book I found about habits. It's another resource, but getting your kids to own and do those things. So here we are at Blast Off. Are you ready? What is that like? Well, that's when it all starts, right? And you're about ready to blast off, aren't you? It's coming up soon. And it's like your kids. They're getting thrown off into space. So look up. Look up. See the moon up there? Like we started there, day one here, and we're headed there, okay? Day one feels safe. It's all good. Out there's day 3. All right? That's when everything sort of falls apart. Houston, we have a problem. The first people to know are the kids, right? They're like, wow, what is going on? Okay? You know? But for you, failure is not an option, right? But one of the things that you have to think about is, what about failing? Because when we fail, we can learn to grow. And when we fail, we're engaged. And so these are actually the story of them when they fail. What are the tools for failing? These were their tools, slide rules, right? You guys got those? You're all ready to go, right? Technology. They didn't have this, but the amount of computing in our phones is more than the computing they had, all right? And people. Now, where do we practice failing? Practice failing, right? Well, you have to practice failing, and this is one of the things they did. This is the simulator. And so on that mission, they had a power problem. They needed a way to save power, so they turned all the power off, and guess what? They didn't know how to turn it back on safely. So these guys sat in simulators for 70 hours trying to figure out how to do it. But that's what school is. School is a safe place to practice. Making your room safe places to practice failing, because they need to be engaged. They need to look at those tasks. How do we practice failing? How do we do it? Again, why are we practice failing? Okay, but how do we do that? Well, it's about engagement, right? And this is the story. These guys had to build a solution out of junk that they had available in space to scrub their oxygen. But they do it together. And so engaging your kids together is part of the piece of failing. And why do we practice failing? Well, we practice failing because when we practice failing, we end up succeeding. we're engaged, we're committed, we're picking tasks that are there, and because failure is not an option. They practice failing so they could bring those kids home, and so it impacts these kids too. All right, thank you very much. And Will, if you have extra tickets, I'll give my book away too.
Oh,
if you'd like.
all right.
I like a bonus prize.
Yes, what a treat. All right, thank you. So for Principles to Action, 714328. All right. Who knew that our winner coming to the stage is also the designer of our great DC Math Ignite logo? If you could give her a round of applause for that. Okay, our next prize tonight is a set of angle legs. And they are a great tool to use in the geometry classroom. You can talk about triangles and quadrilaterals and angles and shapes. I do apologize, when I ordered them off Amazon, I got the overhead one. Sarah, one of our master teachers, Sarah, this thing called an overhead projector, what is that? Maybe you could tell some of us later what this is, because we're not familiar with this. Okay, she said she knows what it is. Great, okay. Oh, we got to raffle it off. All right. Winner, 714348. All right. Great. Okay, we'd now like to welcome to the stage David Tansey. David is an MFA master teacher, and he teaches at Dunbar Senior High School. When asked what one thing he would like to change in his classroom for this school year, he said, just one thing? Let's give a warm round of applause for David.
Good evening. I am, I believe, the halfway point. So when you're done with me, we're halfway through. So I'm a teacher at Dunbar. I'll make sure I get this started right. And a project I started my very first year is the College Collage and Career Analysis Project. Because I have a rule in my class. If I can't tell you how you're going to use what we're learning in class, we don't have to learn it. It's proven to be quite useful. And I realized I needed it because I came to class and I saw my kids were bright, my kids were ambitious, but they had no idea what they were up against. Their idea of what happened after high school was just sort of pure fantasy. So I started the College Collage Career Analysis Project. And I went through a sort of logical exercise with them. And I said, the top 10% of boys who want to play football have a decent chance of making it in the NFL. And they gave me, low numbers in their minds, but I was thinking impossibly high numbers, like 10% or 20% shot. So we went through the numbers, and we did the math, and it ended up being 3.4 million people, half of which are boys. They said half of them wanted to play football. Ended up being like 0.01%. And even the NFL Players League says it's 0.2% if you played football as a senior. So then I talked to them about getting a job, planning for success. Do you agree with this statement? If I'm qualified for a job, then I should get it. And they all said yes. And I said, how many jobs did you have to apply to before you gave up? They said 10. So I said, well, that's tough, because at Starbucks they get 302 applications for each job. So we asked, can you plan for success? And we said, let's work backwards. Let's start from when you're 30, near death. Where do you want to be? And we start with your vision. You say, how many kids I want, where I want to live, and I use the Economic Policy Institute's family budget calculator. You see, to live modestly in DC, you need to be making $89,000 a year if you're married and you have 2 kids. So we go, what kind of jobs? Pay that, right? So we go through the Bureau of Labor Statistics, using their great Occupational Outlook handbook, and we find jobs that pay at the median wage and are considered growth, high growth jobs. There are about 141 jobs. I have them all up on the link that was on the last sheet. I've got them as a spreadsheet for my kids. So I picked 2, actuary and nurse practitioner. Here's a fun comic about the good days and bad days of an actuary. They make similar amounts of money. Their job growth numbers are fantastic, 20-some and 30-some percent. One requires a bachelor's degree, one requires a master's. So then we start saying, okay, I need to go to college. Which college? And a kid will say, but college is college, right? And I said, yeah, right. So they have to pick a college from one of my two lists, either the top 300 colleges in the country or the top 100 value colleges in the country. So these are the top colleges, according to one of the many lists. And then the next is the top value colleges. And you'll see it pays to be military bound. So DC tag is also something to incorporate into this calculation, to have kids understand they can get up to $10,000 a year to go to cover the difference between in-state and out-of-state tuition for any public college in DC. And you'll find there are some clear trends. And we have kids, I used to teach statistics, and it's where I got all this data. We would find trends like, wow, some states, the gap is actually pretty tiny, like the SUNY schools. But you go to California, and you're still paying 20-some grand to go to an in-state school. Then my kids have to go, how do I get into this college, right? Because I picked some pretty good colleges. But most of my kids don't know how to calculate their GPA. And they don't understand just how much an F sort of digs them in a hole. So we go through the calculation. What's the GPA you need for that college? What grades you need to get from my algebra class to your senior year in order to have that GPA? And then we start graphing data. You have a career, you have a plan to get there, you know that you can't fail my class if you want to get into a top college. And we start doing some graphs like interception. So if you're a nurse practitioner or a financial clerk, you're saying, yeah, but I have to go to college 6 years, I go into debt, et cetera, et cetera. We come up with the equation, sure enough, they intercept. After 10 years, you know, you're in the black, in the red, wherever you are, you're making money, and you see your lifetime earning that you get lots and lots and lots. So I have a quote on my wall, a dream without a plan is just a wish. So I tell my kids, I don't care what your dreams are, I care what your plans are. And that's what you can get out of my class. And for 5 years now, I've been running this project, and it's been one of the highlights of my year, every year. So thank you.
All right, thank you, David. Our next prize is, wait for it, some tape measures. Not only do these stretch 150 centimeters, there are inches on the back, and like all great tools in a math classroom, they make a lot less noise than rulers, so you can pass them out. Did you just say they stretch? They do not. I guess when you untangle them, they technically stretch. This isn't an English classroom, so who cares about that? All right, our winning ticket, 714322. All right. Okay, we'd now like to welcome to the stage Noelani Davis. Noelani teaches at Eastern Senior High School. When asked what she hoped to improve most in her classroom this coming year, she replied, mathematical endurance and task-based assessments. Let's give a warm round of applause for Noelani.
Alrighty, I'm short. All right. Good evening, everyone. So, my name is Noelani Davis. I teach at Eastern Senior High School in Northeast DC. The title of my talk tonight is called Finding the E Factor. So, the E Factor, that's kind of our spin on that popular education tagline, the joy factor. So, I'm going to start off tonight with a magic trick. So, I need everyone to close your eyes. Okay. Think of a number between 1 and 10. Multiply the number by 9. Take your 2 digits that you get, add them together, add 4 to your number, massage your temples. Your number is 13. How did I do that? Okay, is it magic? So I'm in a room full of math educators, so I'm sure most of you know it's not magic. It's just us taking the great properties of the number 9 and kind of just, having fun with it. So my first question is, why don't we teach kids math this way? Why don't we give kids, why do we take the joy or why do we take the E factor away from math? So We've definitely become a generation of worksheets, handouts, standardized test prep, all these different things, and all in the name of when we do all of these things and we justify it with, well, the kids come in with deficiencies, the kids are low, we're trying to build. But, again, my question is, why do we do this to kids? Why do we take the joy out of what they know? So up on the screen now, I have some kindergarten multiple choice worksheets. I actually did a school visit in DC, and I watched a room full of kindergartners learn how to count on a handout like this. Why do we teach 5-year-olds how to count on a worksheet? Why don't we give them things to hold and touch and play? Literally everything that we know about early childhood education, and up on the screen, if you're not sure, these are some of our really famous educational theorists. Everything that we know about early childhood education says that kids learn best through hands-on play, discovery, investigations, but we've gotten completely away from that. It's 2014, and behind you, I have some kindergarten schedules of children. Why does a 5-year-old schedule look more intense than my daily schedule? Why do 5-year-olds have 3-hour reading blocks? In contrast, I've got the school schedule for, and this is a school, Murray in Northwest DC. It is a private school, but look at the difference in the schedule. The kids have varied learning activities. The kids have specials. They do all types of different things. So what is the end result? What are the implications of this? But this is what kids believe. Algebra class is only important because we have to pass the test. We've completely lost our joy factor or our E factor. So this data is, I pulled this from the OSSI website, and this is data that deeply, deeply affects me. So if we look at our 4-year graduation rate in DC, it's at 64%, which is not that bad, but we know if we were to disaggregate this data, in our lower income schools, it's much, much lower. This is the most recent DC CAS data, which was just released last week. And you can see the groups that are hit the hardest are the groups that we serve, the economically disadvantaged and our special education students, the students we know the most need something different. So, and this is a quote that I pulled from the New York Times. The skill of math is not a juggling of numbers. It is recognizing a pattern that greatly simplifies the calculation. As soon as I read it, I was like, oh yeah, the E factor, the joy factor. So I'm proud to share that I am a member of an organization called the Master Teacher Project. It's funded, and it was funded with the it was funded through the Bill and Melinda Gates Foundation. So this program's goal is to kind of bring us all on the same page and unify instruction across the country. So it was a nationwide search. Teachers from all over the country applied, and we finished with a group of 46 teachers. We represent all different types of socioeconomic groups. We all teach in different types of schools, and the idea is just to be a resource for teachers. So what you guys are starting to see now, these are my actual lessons that are up on the site. My entire school year is up on the site, as well as the lessons of 45 other teachers. And again, the idea is to create these lessons that bring the joy and the fun back to math. So this is a lesson that's one of my favorites. It teaches kids about systems of equations by having them compare the heights of foam cups versus styrofoam cups. The one that passed was a lesson where I taught students how to solve multi-step equations with gummy bears and M&Ms. And lastly, this is a factoring lesson where kids are factoring with algebra tiles, but they'd also learn how to add, subtract, multiply, divide with them. Completely different than what many people have already done. So behind you, these are my students. Every single day, I feel the joy in them, and I definitely feel my E factor every single day when I'm with them. I fall in love with helping them fall in love with math each day, and I feel like each day as educators, that should be our goal. And that's it. Thank you.
Okay, thank you so much, Noelani. All right, our next prize is a book, Powerful Problem Solving. This book is written by Max Ray and the folks at the Math Forum. It is an outstanding book on problem solving. The Math Forum is a great organization. They run a problem of the week. They have a great newsletter that it's worth signing up for. They do a lot of wonderful work, and they have students write in solutions to problems, and then they give them feedback in writing, and then they announce their winners and they post solutions on their website. This book is chock full of resources. The I Notice, the I Wonder strategies in here. It's a really great read. Again, most of you won't win it, but I encourage you to go out and buy it. Max is a great guy. Winning number 714343. Hey! We coached together. Great. Wonderful. We should actually probably give that to somebody because I own a copy as well. So let's raffle it off again. I can't do that. All right. 714-331. Hey, there we go. Well, all right. Our next prize here is some patty paper. 1,000 sheets of hamburger patty paper. While this is wonderful if you plan on getting 1,000 more burgers grilled in the next couple weeks, it is an even better manipulative for the math classroom. Great for teaching transformations, rotations, properties of triangles, quadrilaterals, everything in between. Good, cheap tracing paper. While many people won't win, if you stop by Whole Foods on the way, you give them a sob story about being a math teacher in DC, they will give you some from the back, and you have a full year's set. A great tool to have, and the Whole Foods folks are really great. You're paying so much for the other stuff, they might as well give you something free. Winner is 714321. All right. Okay, we'd now like to welcome to the stage Bill Day. Bill is a Math for America master teacher. He teaches at Two Rivers Public Charter Schools, and he was the 2014 Teacher of the Year in Washington, D.C. When we asked Bill what he'd most like to improve in his classroom this year, he said, "I'm looking forward to explicitly teaching and assessing scholarly habits such as hard work and being a team player." Let's give a warm welcome for Bill.
All right, I'm going to get into this in a second, but just watching all these, it reminds me, we need to document our work. You got to document work. Take pictures, scan stuff. That's the way you share, and that's the way we build expertise. And I'll also say that doing one of these is like packing a suitcase that you're trying to carry on for like a 14-week vacation. 14-day. 14. Okay, so just click. All right, so I'm Bill Day, and I teach at Two Rivers, and I want to share with you a practical routine that I have been using the past few years. But first, I want to dig into some of the philosophical underpinnings of this technique I call critique. Who can name this document? Common Core, right? Lays out content standards, lays out standards for mathematical practices. Each one of these kind of gives us a different foundation for what math is. The content standards sort of frame math as a set of procedures and rules, things that students acquire and have. The practices frame it as things that students do and participate in. These aren't mutually exclusive, and in fact, it's important to teach both of them as we go through, but they have different implications for what the roles are for teachers and students. In the top one, teachers deliver, students receive. In the bottom, students have to generate, and teachers prompt and guide. And these lead to different lesson formats. The lesson formats that goes with the top one may be the I, we, you, which is a gradual release. And then there's the you, y'all, we, which is where students sort of experiment, gather ideas, and then those ideas get legitimized by the whole class, including the teacher. And the problem that I see is that this top one tends to get done more often. This is a problem because students get a stilted version of what math is and how applicable it is to their later life. And I think part of the reason that we do that is because we were probably taught that way, and there's not a lot of very applicable models for how to teach you, y'all, we. And so we get to my proposal, which is to implement a system of critique. And it's a way that I think we can make you, y'all, we actually happen. It's a technique I learned from a guy named Ron Berger, who's a key thinker behind Expeditionary Learning, which is an organization that partners with my school, Two Rivers. And I'm going to share a quote with you. In carpentry, there is no higher compliment than this. That guy is a craftsman. This one word says it all. It connotes someone who has integrity and knowledge, who is dedicated to his work, and who is proud of what he is and what he does. Well, what if we could change carpentry to mathematics? Also, could we change it to be gender-neutral language? But wouldn't it be great if we got kids to take pride in their work and really apply it as a craft? And I think critique is one way to do that. So what is critique? Well, there's a couple steps to it. First, you give students a problem. then you look at samples of student work, and then you collectively name and identify criteria of high quality, and then you revise the work based on that criteria. So let's say you're going to teach a lesson on creating dot plots. You give students a model and then say, make a new one with a new set of data. So the students do that. That's the you part of the critique. And what happens is you get this work, and you intentionally, as the teacher, intentionally selects a few pieces that showcase both strengths and weaknesses. And now, as you imagine, when you show something that has some misconceptions, it's very intellectually vulnerable for a student. So you have to take these rules, be kind, be specific, and be helpful, really establish and enforce these rules so that students, when they look at work that has problems in it, they can, one, look for the things that are right about it. So like here you might say, based on the data, that the frequencies that the student has selected are right, but they can also kindly and constructively say the x-axis is missing some values. So what do I give my students to be able to do this? Well, I have a note catcher that I like to use. Before we even look at the samples of the work, we brainstorm, well, what are some vocabulary that we think we should use when we talk about this? And also, what's good work going to look like for this problem? So you brainstorm that, and then you look at the work. Use the stems, I notice and I wonder, work wonderfully here, and you actually end up revisiting the vocabulary and criteria for high quality. This is sort of the y'all. We're looking at what y'all do. And then to push it to the we part, well, we involves I doing it. And so you think about what are you going to change based on what you saw. Put the students in that space where they're thinking about what are they going to do better this time. And it requires multiple times. You got to do multiple drafts if you really, that's what crafts people do. And when you do that, you get students that, they're not going to necessarily make it perfect the next time. There's mistakes in this next version, but they're going to do better, and you can do another critique. And I think that this protocol and this sort of format for lessons is one way we can make the you, y'all, we really happen in our classroom. Thank you so much. Contact me if you want some resources and stuff.
All right, thank you, Bill. Now for our final prize of the night. Great. Our final prize of the night, a math symbols poster. Very big, very beautiful, a great thing to put over the mold in the corner of the classroom. It's a really great one to have. Definitely want to take it home. Winning was 714339. They left. Stinks for them. Next, 714355. All right. Okay, before our last speaker, I want to give a huge thanks to our hosts tonight, Math for America DC and the Carnegie Institution for Science, for being such generous hosts. They've been incredibly gracious to us for providing us this beautiful space this evening that even has a moon, which I did not know, and I don't. Did you know that before you said that, David? Oh, okay. Yeah, wonderful, wonderful use of the room. Thank you to the building staff for helping us prepare the space, for John, our videographer up there, for Mark, running our AV from Pro AV DC. A special thanks to Julia for designing our logo, and who's also an MFA fellow at Capital City Public Charter School, and designing all the flyers for the event. Maxine. Thank you for that. Great. If you have more questions about that, you can ask Maxine at the cookies afterwards, and she will tell you more. We'd also like to give a huge thanks to Marlena Jones and Bianca Abrams for all of their hard work they do in running Math for America DC and building a bigger community of math teachers every year. We appreciate all the tireless work they've put in and their flexibility in making this night happen. We'd now like to welcome our final presenter to the stage, Sarah Bax. Sarah is a Math for America master teacher, teaches at Hardy Middle School, and when asked about what she'd most like to improve in her classroom this year, she said, "This year, I am relaxing my search for perfect problems and instead focusing on developing rich student discourse." Let's give a warm round of applause for Sarah.
Last one. I remember when I was in grade school learning the terms metaphor and simile, and I was truly like mesmerized by this idea of explaining something using something else. And indeed, through my life, the use of metaphor has really come in quite handy. Sometimes explaining to a friend how they just have to push through the fog to get to the other side of a tough situation. They can't run around it. And I find I best understand my own thoughts, by relating them to a different set of ideas, a set of ideas that is familiar to me, that I can visualize. And when I think like this, I just feel, more complete about my idea. In fact, I've realized that my teaching practice is actually quite full of these types of expressions, and I'm convinced that the use of this metaphorical math, as I've coined the term, is a splendid bridge from teaching to actually learning. And I'd like to share a few examples with you, with the hope that they might bring some color to the black and white Xerox copy that is sometimes called math instruction. And see how I slipped in a metaphor there? My first and largest metaphor, as has grown with each year's telling, is that of integer land. This concept, as most of the best ones we have as teachers, occurred to me in the midst of a math class, in the middle of teaching a different lesson. And yes, for integer land, I exposed my students to this violent and irrational truth that integer addition and subtraction is actually, in fact, only the written recordings of the ancient civilization of integer land. -4 plus -5, well, who showed up? 4 negatives and 5 more negatives. Was that a fight or a convention? A convention. Well, who was there? 9 negatives. And -7 plus 4, well, who showed up? 7 negatives and 4 positives. That was obviously a fight to the death, no less, as that is the code of honor in integer land. If I kill someone, then I take my own life out of honor for my group. That doesn't make sense, someone's sure to say. Well, not to you, because we live in a rational society. And then I love to throw in that great lecture about how we don't judge other cultures based on our own cultural mores. And who would have won that fight? Well, it's obviously the negatives won, despite what the slide says, by the way, and with only 3 left alive at the end. So that's why it's recorded as such. And I have to confess that I usually pass out yellow paper and red paper, and we make hats, and we get the meter sticks, and we use them for swords. And we battle until kids fall down on the ground, and there's blood gushing everywhere, and watch out for that head. It's rolling down the aisle. This from a teacher that calls herself a pacifist, by the way. But what I've found is that when I use this, students actually get the idea and they retain the knowledge. I won't go into subtracting negatives. Well, that's just somebody double talking you, and you have to stop that double talk. And multiplying and dividing integers, well, for that we get into the anatomy of a healthy marriage. Which axes hold the independent variable? Well, let's think about this one. Should your ex-boyfriend or ex-girlfriend be waiting at your stoop when you get home? Should they be texting you 37 times a day? No, they should be independent of you. Otherwise, it's called stalking. Linear functions, well, they're the amoebas of the math world. They only have 2 characteristics, slope and y-intercept. What if the world was like that? All of us were exactly the same, except for only 2 characteristics. The same family, the same eye color, same hobbies. Well, it'd be pretty simple, probably kind of boring, but pretty simple, just like linear functions. In reflecting on my practice of using metaphors, I realized it's not just the conceptualization or accessing prior knowledge, it's really back to Maslow, somewhere between safety and love. Students need to feel that they're cared for and that they're part of a larger community. By infusing many of my metaphors with a message that goes beyond math, I meet that need. It's really the attached life lesson that students are so hungry for. So If our students want to eat brownies, let's get some life lessons. We just need to sneak some black beans into the recipe. That's Common Core state standards.
Okay, thank you to Sarah. Thank you to all of our wonderful presenters tonight. Before you leave, I want to plug a few things. Thank you in advance for filling out a feedback survey on this. We'd love to know what you thought of the event, but we'd also be interested if you feel like, man, you've got an idea that you'd love to share and you want to sign up for the second Math Ignite night. We'd love to have you, love to have your colleagues out to share that. Several of the presenters up here work with Math for America, and we're going to be running a ton of professional developments throughout the school year, and we'd love to invite you to those. And so one of the options on the feedback survey would be, would you like to receive emails? If you'd like to come out and talk and reflect on your math practice with us, we'd love to have you, and we'd love to keep building this community of math teachers in Washington, D.C. You were all invited for some cookies in the ballroom, but before you leave, your homework for tonight, because it's that time of the year and we've got some homework. I'd like you to really think about choosing one idea that you liked from tonight, and I'd like you to keep the conversation going with the other educators in the room so that we can keep sharing all of these best practices. Thank you for coming out, and have a great evening.